This is Jonas Kaff for Sensor Technology Task 2. For this project I've been using servos to bang certain objects over a certain period of time to create some form of generative music. This is the sketch that I've been using. Up first, a few links I've got here. The first one is a question that I posted on the Arduino forum requesting help. This is a link to a thread that I was directed to by someone on that forum, and here is a link to a video by Christian Hofstadter, who helped contribute to this project. First line of code, obviously including the servo and defining the LEDs. Next we move on to the servo objects. This is just naming each servo 1 to 6. Then the position store. I believe this is a default position for each servo. So each servo, the default position is 1000. Here is the servo interval, so effectively it's a way to set the time that each servo triggers. See, this one here is half a second, this one here is 100 milliseconds. With this one, interestingly enough, because the time period is so short between each cycle, the servo didn't always make it to the end of the cycle. It would sometimes stutter, and I found that quite useful for the guitar, because rather than just strumming all of the strings all of the time, it would sometimes strum all of them and sometimes just stutter and just strum a few of them quickly, which turned out to be a happy accident. This one here is a variable for the timer, and further down, if we just skip over to the move servo section, each servo has one of these, and you'll see the servo timer equals millis. So millis is it's how many milliseconds since the program has started. So the servo timer is the millis. Looking at this loop here, you'll see an if-else statement. The if statement is saying if position 1 equals 1000 or lower than 1000, which it always is by default, then send the position to 2000. Else, send the position to 1000, thus triggering the if loop again, the if statement again. Scrolling back up here, we have this is just attaching the servos to each to a pin using the pulse width modulation pins, and here are the LEDs that I've got set to output. So yeah, we've explained this. There's each servo has their own loop here, their own if-else statement. So going down to the loop, it then says if millis take away servo timer is larger than or equal to servo interval, then move the servo. So this is the loop, this is the part that actually commands the servo to move. And then also here I have the LEDs flickering on and off. The delay for each one is very small, so they're flickering very quickly, and I've done that so that the delay, if you add too much delay, it's going to affect the timing of the servos, so I didn't want to add too much, so they're just flickering. And the LEDs are mostly for aesthetics anyway, so that's not too big of an issue. I'll now move over to my other camera to demonstrate the project. Okay, so here we have the project. As you can see, there's quite a lot of wires here, so I'll try and demonstrate as best I can. We have here, we have the LED pins. Then all of these are the servo pins, just pins that control the servos. So each servo wire leads in to a servo. If I demonstrate this one because it's got the most space, you'll see the pin comes in here. Then the yellow one here is connected to the pin. Then we have power and a ground, and each one is color coded the same to keep things organized. Also, the LEDs are connected using I believe 220k resistors. Also, here I have a power supply, which if I turn on, this one here actually only controls these three. One connected to a shaker. This one is the guitar strummer, and this is hitting a glass for a sound there. The other ones are running from the Arduino power source, which is being controlled with this switch. So these three can be turned on and off separately to these three. The other three I have, this one is moved, but I actually have this hitting coconut oil because it sounds quite similar to a drum. I also have another shaker, and this here is a chopstick that's moving a bell.